Let's do it. I get up the spreadsheet, I guess. My dog has to go out.
On it. Okay. Where did we leave things?
I think Timothy added a few simple things where he thought we could
clear up. Yeah, that I remember. Yeah.
The syllogisms, yeah.
And this manifested as, I was cleaning up. Stephen, Tim 2, where's Tim 1? Because I think it's the best now, and Tim 2 I should remove. Like this is map scoring go, map declarative go. I think this is the most recent one, so this goes. Okay, good. These two can wait, but I'll just move them out of view for now. This is not relevant anymore. I'll keep that one in the background, but really what we're looking at is this.
Right, yeah.
I'm a bit surprised. I thought there was something else since there. As we said, this doesn't seem like it's the latest. 1 second.
I think we had a Tim 2 file.
Yeah, but I'm not sure it's earlier.
Just order by last modified.
That's exact. Yep, this is it. I need to make that binding implicit. Nope, that's the same. Now, what we did last time is the is support thing. But I thought we had also done the multi-premise.
I think last time was the syllogism thing, like really like 51 here in the spreadsheet. 51, 52, 53.
It is Tim 2. Okay. You are correct, my friend. It is Tim 2. Premise is multiple. We have proofs conclusion now. We had is support at some point. Do we still need is support?
No, that was a few sessions earlier, I think.
Yeah. I think it's gone. I think this is the string star sentences, claim negation.
Because we did this one-to-one relation for negation.
Yeah.
And this way we didn't
about that, guys.
Support anymore. No problem.
No problem. Yeah, okay. No, sorry, it took me a while to remember which one is the latest between Tim and Tim 2. And okay, these are the changes we made, multi-premise and the proofs conclusion.
Yep. I mean, I've had some thoughts over the week. I know I can't remember, so forget it. It's not important. It's something about reasons why I never made arguments be a subclass of claim.
Let's start recording.
It's already recording.
Oh, sorry.
I think it automatically does it. But yeah, but I don't remember the reason why, so it'll have to happen again naturally at some point. So yeah, there were. What's that?
No, I'm trying to reparse your sentence. Reasons why arguments, please repeat.
Are not a subclass.
Oh, reasons why I didn't have arguments as subclass of claim.
No, that's interesting.
Yeah, and I can't remember what my realization was. And it's not a big deal. It's the kind of thing that is, more like just alternate ways to model and what thing you're favoring in your model. But
right.
In the end, the support is the same. But hopefully I can think of an example at some point when I remember why. Right now I can't.
what
Okay.
pops to my mind is
Um,
that if you have claims and arguments separately, then claims are root nodes in a kind of argumentation tree. And if everything is a claim, then everything can also, I don't know if everything can be an argument, but then it's not a tree anymore, or not, doesn't have a root. Everything can support anything.
Oh, I'm pretty sure that's true. I don't think it's a rooted tree.
Yeah.
Or a rooted graph.
But if it was separate, then you have different structures. If not everything.
there are good reasons why I've accepted that support or is a type of claim, because it's kind of like, if this support is valid and true, then that supports other supports, and that sort of thing, sort of the analogy approach or something like that. Yeah, we'll try to revisit that at some point. You're scrunching your eyebrows. I think you don't quite remember or understand the example I gave, Felix.
What? Sorry, no, I didn't. And
you want me to go through that again? That what I said about using a support. The question is, a claim can be used to, as the basis of a support of something else, right? And that support is defeasible. It can be valid or invalid depending on whether or not that base claim is true, right? And where does that happen when you're talking about an argument? Where can you use an argument as the base of another argument is the question. That's a fundamental question of, is a support a claim from a model perspective, right? Is because claims are canonical, and that you can talk about whether or not they're true or false, and that fact can then be reused to support or oppose other claims, right? And if a support itself is a claim, then what does it mean that a support is true or false? Well, a support as a claim is the claim that this claim supports another claim, right? So it's the act of supporting that is true or false. In other words, it's valid or not.
Wasn't that, didn't we say earlier that this is the relevance?
I call it relevance, yes. So the truth of a support is what I call relevance, right? So if it's a relevant support, right, that means that the claim that the support makes is true, right?
Yep.
Now,
something I think we all agree on at this point.
Yeah. So, but then the question is, can a support be used as the premise of another support? That is the question. And would it ever be, right? And the example that we came up with that was interesting, but I haven't seen it in practice, is what you could think of as an analogy. It's like, well, if you accept that this is a valid argument, then you should accept that that is a valid argument, right? If you accept that I can say this, you should accept that I can say that, right?
And if you don't, you have a cognitive dissonance, basically.
Well, it means that
well, you may have to prove, you may be able to defeat the analogy. Say this analogy doesn't stand because those things are different in this fundamental way.
Yeah. Mm-hmm. Yeah. It's a bad analogy, sort of thing. Yeah. Anyway, that's not where I wanted to go with this. I wanted to go with the bottom up process.
It is a good question whether support are ever premises versus conclusions. And I think that is a valid example. I agree it's a bit rare, but it is a valid example of where support is used as a premise rather than a conclusion.
Right. This is the sort of thing I would really want to see in practice, right? And I guess I see it in practice in conversation, more informal discussion, but I've never seen it in practice mapping out a debate. And that doesn't mean it wouldn't happen. It just means maybe the kind of debates I've been mapping out are more fact-based or that sort
Or
of thing. Right?
maybe that the tools didn't support it, but did the tools?
No. I mean, literally, like if there are things I've tried to map where I've been like, okay, the tool isn't supporting this thing, so I'll have to, I'll have to hack it in somehow. The example, our main example being the lockdown versus human life or economic cost. Lockdown, human life, and economic cost debate, right? No tool we've made so far fully supports that. But
the main cases I can think of support as a premise is basically application of inference schemes like modus ponens, right? A implies B, A hence B. It's a bit tautological almost, modus ponens, but on the other hand, it's saying, well, A implies B is a valid, modus ponens is a valid inference scheme.
Yeah, but like logical fallacies, like when you accuse something of being a logical fallacy, for example, as a way to try to defeat it, I've always seen that as you have an underlying claim, which is like ad hominem is not a valid argument, right? Or not a valid.
I see what you're saying, but
yeah. And then
it's, yeah, well, it's always, I guess, well, but this is exactly what treating the support as a claim means. It means, is this inference scheme, I mean, the generalized support, like support as an instance of a pattern, right? And is the pattern itself valid? I claim this pattern is valid in general, that I'm treating the support as a claim, or rather the generalization of the support as a claim. And this is where I think the instance general, instance abstract relationship is interesting, because there's kind of two claims. There's A, modus ponens is valid in general, and B, this is a valid application of the modus ponens rule in these premises, right? There's again an implicit claim about the modus ponens instance, and there's an implicit claim about modus ponens generic validity. So there's two claims here, if you really want to unwrap things.
And you would write it out as, this is an application of modus ponens. Is an example of modus ponens, right? Would be the claim that you're using to support the argument, right?
Yeah.
And then you would have the modus ponens as a definition.
Yeah.
And that definition is a claim or not. Those are some things that are going to hurt to break apart.
Yes.
Yeah, because I'm not yet comfortable with the definition and definition as claim and all that. That's it's a topic I want to dive into soon, but after we finish a few of these simpler.
Fair enough.
The
fair enough.
fair
like
enough.
Yeah. I agree that the definition is something that fascinates me. Obviously, the abstraction is really something I want to get into, but. Okay, reusability of OR premise in a multi-premise argument. Should we go there?
Sure. Yeah, these are going to be pretty trivial, I think. I wasn't able to come up with a good example that I wanted. But let's go ahead and look at the example for 54. I mean, I guess we're in the phase anybody else could suggest something else, but are we all good with doing 54? Okay.
Yeah.
Actually, so let's do 54.
It's not that trivial, this one. I don't know if it's essential, but the OR, we said these are independent supports. So the collection of support is not materialized. So reusing something that is not materialized may not be trivial. I don't think it's a big deal. I don't I'm okay with reusing each support independently rather than reusing them as a materialized collection. But I'm pointing out.
Let's look at the example here. Maybe if you can uncover it there so we can, so Tim created the example or Felix created the example, supports one of us created the example, right? And then the other one is at least one of us being the CDL group or whatever, has editing rights to this document, right? So you could just go ahead and repeat the structure of, oh, I made an argument that Tim created this example, and then somebody else makes the argument, no, Felix created this example, right? And we can debate each one separately of which is true. In the end, if either one of them is true, it does it, and you've not needed to carry on a structure, right? The interesting thing here is
supports. We have two supports here. Tim created this example, supports one of us created this example. Felix created example, supports one of us created this example. And those supports are not tied.
Right.
Yeah.
So it's not the most interesting example because an or. I added the or thing later because I was going to find an and that requires that. But one interesting thing to reflect on here is there's a second way to create an argument in support of 4, right? Which is you support 4 with 3, right? If 3 is true, one of us created this example. It's a much shorter way of arguing in support of 4. It's collected all those ors under one grouping, right? And that begs the question of, is there an optimal or most efficient structure to an argument map, right?
How did we model the or before, like 53?
We didn't, because what we realize is that it's an implicit or. If I create 2 separate arguments that ice cream is good, right, and I say it's good because it makes people happy, and then I say it's good because it increases your blood sugar level, whatever, it's nutritious, right? Only one of those needs to be true for that to be correct, assuming it's deductive, assuming deduction. Forget it only partially proves something.
I think your earlier example was better.
It is better, but I'm just trying to give a different example, right?
Yeah.
But at any rate,
ice cream is good in at least one way.
what I'm just trying to show is that it's not an and relationship. I've created 2 arguments, and they act independently. And 2 things that act independently, and if either one is true, then the result is true, is an or relationship, right? Whereas if the argument was that ice cream is good because it makes people happy and it's nutritious, and they were both necessarily true in order to prove that, it's a different kind of relationship. You defeat either one of them and you've defeated the whole argument.
Okay, makes sense. So then how did we model 52 at the end?
We didn't have to, because having multiple supports is all you need to model an R.
Multiple premise.
Oh, how do we 52? How do we do 52? Good question.
There's an implicit and in multiple premises. That's the
So go back to the model. The way we implemented it was turning claim premise into a list of premises with an implicit and relationship. So you do it through the support. Does that make sense?
I think so. Yeah. Okay.
Okay. It doesn't handle more complex logic relationships. We haven't gotten there yet.
Yeah, it's not very beautiful, but it works, right?
Yeah, and
it's beautiful and to me because it's simple, but I think it's going to get uglier.
I think I'm quite happy with it myself, because basically this is an expression of disjunctive normal form. Any propositional calculus can be expressed as an or of ands. The support is the and multiple support is the or. That's it.
I remember you saying that. Yes, that's true.
Yeah.
So we have the full Boolean power.
Yeah. Actually, I just want to go back on the ice cream is good thing. 2 seconds. I said it's a bad example.
Okay.
I think it's actually a beautiful example of something that is not propositional calculus. I would actually say that if I say ice cream is good, I'm saying it's generally good, meaning it's good in many dimensions. And if you have it's good on one side and bad on the other, it's not overall good. So it doesn't need to be totally good on all dimensions, but it has to be at least overall good on as many dimensions as possible. So I would argue for something like a vector product or whatever has the, not an and, but maybe at least a min or vector product.
Well, the way I handle it in the scoring algorithms I do, it's essentially, it's like weighting, right? And this is the way also a reason score works to some degree, where it's like each argument in support that you add adds weight to the true side, and each one in the, you know, on the opposite side pulls it down towards false. And there's like a math that handles the weighting of it.
And what I'm saying is we don't have the way to handle that yet, because what we have is a pure and absolute necessary condition, which I think is what we meant by multi-premise. And we have a pure or absolutely independent condition. And this kind of multiplicative conditions we can't model in this model.
We don't have any notion of scoring. We don't even have a notion of true or false here. It's implied, but we haven't modeled it. There's no way to record if something is true here, right?
Yeah, what I'm saying is it's not just a scoring problem. It's a certain kind of relationship between truth values, which is not an and, not an or. It's a, let me call it a vector product. And I haven't seen it in, it's not just about scoring is what I'm trying to raise. I'm not saying we need to do that now. I'm just raising that for further.
When you say it's not about scoring,
I'm saying,
do you mean it is also about something at this level that we need to capture in the model? Or
yes, I'm saying it's something. Yes, I'm saying that. I'm saying we should, and I'm not saying we need to do it now, and I'll think a bit about how to reflect that, but
like I would think the opposite, and you know, so I'm agreeing while disagreeing. I'm inverting the sign. You might say.
Cool.
Here's the thing. I would say it's. Yeah, I would say that this model implicitly supports that approach, and because it's deductive logic and other forms of logic that are, you know, it's the proves conclusion flag we've added there so far, right? We added a proves conclusion because until we added that proves conclusion, it was assumed that it didn't have to
everything
prove the
was
conclusion.
sufficient.
It was supporting. It was supporting it.
Supporting
somehow.
versus sufficient.
Whereas,
yes.
Yeah. And that's what I mean by this is I think as we tease out more of these formal logic structures, it will separate itself from what is,
Interesting. So what you're saying, and I think you're probably right, is if I had, like, say, 4 criterion of goodness, let's say, and I'm arguing that ice cream is good would require kind of some combination of positivity of all 4, or at least if there's a negative, it has to be weak and overcome by the other ones, kind of things, right? Kind of some weighted average, which I said is not scoring, but, you know, if it's too wrong, it cannot be good on any one axis. What you're saying is what can be modeled by 4 independent support arguments, which would not be proving, which would be, you know, weak supports as opposed to absolute support. And maybe also the same structure on the negatives, meaning it being bad on this axis would support it not being good. It being bad on this axis would support not being good. You might want both, right?
Yeah, there's kind of 2 ways to do that, right? Which is, or rather, yeah, you would need it on both sides. So let's say that, and this would have to be handled in the definitions. Your definition of good could end up being, you know, either a list of categories, or it could be, you know, because you could impose rules upon that, and we're not going to go down, we're not there yet,
that rabbit hole,
which would be like, yeah, exactly. There's four criteria. Is it increase overall happiness? Does it increase overall health? Does it increase overall?
We don't need to name them. Let's just
improve the environment. Let's just say there's 3. It improves the environment, impact on
cool.
the environment, health, and overall happiness. Okay.
Cool.
You could add a criteria that says if it's negative on any one of these, it fails, it's bad, right?
Yeah.
That would be an extra criteria in the definition somehow that
But
would have to
this,
also be
isn't this
reflected.
criteria just and logical and?
No, it would be a logical
Well,
or actually. That's why I'm saying there would be three, because it's any one of these means it's an or. So that means negative environment is one support claim for the bad. So negative environment supports ice cream is bad. Negative health supports ice cream is bad. Negative happiness supports ice cream is bad. So that's three support links between the negation of the criterion and the negation of the goodness. And you have three independent support link. Good environment supports ice cream good, good environment.
So can somebody, well, here, I'll write this down to pause because this is another example I think we should do separately. But this brings up a whole section we didn't talk about yet, a whole category, which is compound claims. And this is something that I think Bentley said he doesn't want to support, but we should. He didn't really do it.
No, I'm thinking, do we have it in the incomplete?
I don't know, maybe. And one other thought I had about this while we were going through is there's always a question of, when we talk about disambiguation or definitions, if your definition for good is it's increases overall happiness, it's good for the environment and good for public health. You're using a single word, but you could replace that single word with the text of the definition as well, which is ice cream increases overall happiness. Ice cream increases happiness, is good for the environment and good for public health. Right? Okay. So, ice cream. I'll just put a note in here that ice cream is good was the original sentence and replace the definition.
Mark-Antoine, with vector product, you're basically saying it's not discrete anymore. It's like a
correct,
like a combination. Yeah.
Well, okay, but here's the thing: is what we're looking at is a claim. Ice cream increases happiness, is good for the environment, and good for public health. Right? Is that a claim, or is it not a claim?
Okay, sorry.
Yeah, go ahead.
You were saying?
So look at my claim here on 57.
Yeah.
Ice cream increases happiness, is good for the environment, and good for public health. Is that a claim?
Or is that the combination of three claims? It's a collection of claims. Okay.
Well,
that's a question, right? Do we need to model compound claims?
Right.
Do we need to split it up in the model, you mean? That's a question, right? Or can this sentence stand as it's on its own as a claim? Yeah.
Yeah, and this. Yeah, go ahead.
No. It's a perfectly valid question. I think absolutely in terms of progressive formalization, we have to accept compound claims as at least a stage. Whether we want to drive them towards atomic claims I would tend to say yes, but certainly we have to accept compound claim as a stage. Is it something we want to use or want to, drive relentlessly away from is a separate question.
I mean, a better, like 57 is handled with putting it into one sentence. But if you want to reuse one of these atomic parts, then becomes interesting, right?
We certainly
And you have to support that. Yeah.
We have to be able to say that this compound claim is equivalent to the conjunction of those atomic claims. That is not something we have in the model yet. This claim is equivalent to conjunction of these three claims. And do we need more than conjunction?
Here's the thing is, yeah. I think we need to support the sentence. Obviously, we need to support the sentence because somebody puts in the sentence, right? Yeah. We also need to somehow support the conjunction. Like there's no way to do an incremental formalization of this if you don't support in a more formal way what this sentence is saying, right?
Right.
You can't just say, oh, there's 3 claims out there that are just like this one and not record that in the system somehow and drive people from one to the other, right? Yep. Which means, to me, we do need to support compound claims.
I'm afraid that's the inescapable conclusion, yes.
And compound claims seem to have a logic structure that is part of their truth formula, however you want to say it, right?
Yep.
Now, that being said, do we need to have multi-premise arguments, multi-premise supports, or do we solve that by having compound claims, and making the compound claim and having that be the premise of a support?
Of course, that's the question, isn't it?
That feels right to me. Sorry.
Okay. The reason I was pushing for multi-premise nonetheless is that when you have complex formula, and you may remember I had this whole notion of argument family and different rows in a truth table. And, I've been on and on about this. We're coming back to that, right? Hello, familiar argument.
It happens, yes.
Yes, the point is, in a single argument, we're in a kind of single row situation, A and not B and C or not D and whatever. That's the formula. And then in the next row, it's A and B, and in this other case, we have a totally different propositional formula for the different values that form the premise of the support argument. If we have compound claim, we have to say, I think it would be desirable to say, these compound claims are related because their underlying formula is the same, though they have different truth values, right? Or they're combined in a different formula, but the signature of the underlying atomic claims is the same. That's what I was driving at. That's what I was doing explicitly.
You mean the signature? Are you talking about the logical construct? Or are you talking about
we have
claims that are being used? You're talking about the tables. So you're talking about one is ice cream increases happiness is bad for the environment and good for public health, and another is
we have multiple. We have 3 basic claims: ice cream good for the environment, ice cream, and their negation. So that's 6 basic claims, and we have formulas, a great number of formula, and it turns out 2 to the 3 basic propositional formula, or basic rows in the truth table, because we have 3 premise. So we have 8 truth combinations of those formula. And some of them can be condensed into a single propositional formula, some maybe, but that's not the point. There's quite a few propositional formulas. There's probably 2 to the 3 combinations, groups of formula, right? That's a partition on the rows. So when we say we have a premise that, in this case it supports that, but in a different case it would support something different, in a different case it would support something different, those cases all have in common that the basic atoms being referred to are the same 3 atoms.
Correct.
Modulo negation again, where I'm equating the atom with its negation. And so that's what I call an argument family. They're an argument where the atom set is the same. That's what I was calling signature right now, not the truth values. That's kind of extra. That's how is the combination of truth values used in this specific support this specific conclusion. But if I'm just looking at all the arguments that have the same atom and conclusion sets, I have, they're unified somehow. And we could do it with a formula saying the truth of this is the truth, some formula of the truth of that. And that's where we get into partitions. True if and only if a partition on the truth row set. Or we can have it as separate the rows. Each row is a separate support. And then we can just say multi-premise conclusion, which I think is simpler at a certain level.
I mean, I'm not sure I see where all this is necessary. If we have a compound claim, right, and you have A and B and C.
Okay, you have
just
A
that
and B
logical
and C.
Structure implies every single variation on it, and then you use that to support something else. Then all possible outcomes of the table are all embedded in there. They're all, you don't have to call out separate things. It's just, that if A is false, then the whole thing's false. If B is false, the whole thing's false. That's just what the logical structure does. And you're using it to support. So that, that compound claim can be true or false based on its logical structure. And the support succeeds or fails based on it.
Okay, let me, yeah, sure, that's the easy case, right? But then somebody else says, well, it's actually A and B or C, and then with the parenthesis C on the first member.
So that's a separate compound claim.
It's a separate compound claim. And all of these compound claims can be the basis of a different argument. And then you have, well, a vector combination B and C, because those are synergistic. I said at some point we'll get into probabilistic truth values, and then it's A plus B squared plus 2AB. That's a formula, and that's how the truth of these combines form the probability of the other. Normalized to 1 some way, right? Divided by 5. It's all of these are formula and alternative hypotheses with the same underlying atomic claim signature. And when they're compared to one another, you want to know that you're comparing the same atomic claim signature. And maybe it's the simplest way. You may be right. I'm just saying I'm a bit uncomfortable. The idea of this, making those into separate disjunctive normal form single row supports that are related somehow, but each of them is an individual row. I think it makes it easier to argue things separately, and it makes for simpler structure. But I do also accept your argument about why we do need to model compounds. So I'm a bit, oops, I don't have an answer, but I'm saying I think using compounds as premise will bite us. in terms of complexity when we want to compare complex formula. Just a hunch, but I don't know if I'm.
But I don't think so, because like then by separating it out, right? What you've done is, because another problem we have about the discussion about premises is, what if there's a premise that is totally irrelevant, or shouldn't be part of that group?
Yep.
The place that matters, because a claim is still a claim. So I could say ice cream increased habits is good for the environment and good for public health, and my hair is falling out. That's a nonsensical sentence, but can still be true or false.
Yep. So non sequitur.
It's only when you go to support something else that you go, well, the hair falling out thing is not true. Tim, you have a beautiful head of hair, but
but it's very easy to model if you're either way, by the way, either in your model or the one I'm proposing, because you can show that the hair falling out has no impact on the truth table,
because it can be removed from the logical formula.
Yeah,
there's
and you can make
through.
But what you would do, what you would do in the compound claim approach is you would just say that this
is not part of the formula.
This construction is totally unimportant.
Yeah, that's absolutely true.
You would make a second support with the correct one.
Yeah. And what I would do is show, here's the support with, here's the support without. It's always the same value. That may be more complex. I was trying to avoid formula. It is possible to avoid formula. Is it desirable to avoid formula? I don't know.
Well, we have to see an example, a concrete example where the formula is irreplaceable. It must be there's compound. I think you'll probably agree that there should be compound claims.
Your reasoning is sound. I've agreed to your reasoning for why we need compound claims.
But that a compound claim could be composed of compound claims, right? Because that's how you get the more complicated.
It's fractal
complex
chunking.
Logical statements. Yeah.
I'll admit it's something I was trying to avoid, because it makes canonicality more difficult, because then you have to look at the order of composition. But that's doable. I'm just pointing out.
Yeah, I agree with that.
Anyways, I think we should just go for modeling the disjunctive normal form somehow, make it possible to model that, because a formula usually is just a compression of the truth table. And so we still, if we want to be as expressible as possible, we need to support the full disjunctive normal form, and sometimes there's a shorter way to express it. And it's a different feature in the model to allow simpler forms to express it. But in general, DNF should be good. If we model that, we have almost everything.
True.
I don't know if there's these normal forms for fuzzy logic, Marc-Antoine. When you
Good question. Let me think about that a bit.
What logic? Fuzzy logic.
Fuzzy logic. No. Yeah, that's a good question. I don't know, and it's also interesting to think about it in terms of Bayesian logic. And my answer in the case of Bayesian logic, I think is true, actually, in that, in a way, the Bayesian formula is a way that you can decompose, but it's only in case of independence. But no, you're oh, no, you don't decompose, because you're just flipping the dependency. So you're allowing commutativity. But I think there's a way to flip the Bayesian to a simple product of probabilities. I'll look into it. I think so.
It's a good, because maybe these normal forms, I guess that fuzzy logic normal forms are probably a generalization of Boolean logic normal forms. So if we have if we support the most general one, we support all of them.
There's not a single generalization.
No, but I mean, like, if we support, like, if fuzzy logic normal forms is a generalization of Boolean logic normal forms,
Yes.
and if we support the fuzzy one, then we don't need to explicitly support the Boolean one anymore.
Yes, I was opposing all of them because there's so many forms of logic, and there's not
there's
not a me to the generalization operator on all the logics.
And we need to decide on which level of logic is useful to the system.
Yeah. Incidentally, I'm not a big fan of fuzzy logic. I love Bayesian, but that's different. But
it was just an example. Like,
no,
I
it's an
think
example.
we should go for Boolean logic first, and then see where we need different forms of logic.
Yeah, I agree. So if we have compound claims, it basically has let me call it a string for now, formula and claim atoms. Let me do it this way for now. Let's see if that's what we want. No. Claim atoms. And by the way, no, compound claim. And compound claim is also a subclass of claim. String formula, claim atoms, and is there, and actually in that case, we can have a single premise. Should I make that change? Are we clear enough on this that I'm making that change?
I'm wondering why you're putting in formula there. Because if we model the DNF, then we don't need the formula to be explicit.
Well, that was the first approximation.
Okay.
How do we combine the atoms? Do we want to model it at the object level, or do we want to model it at the language level? The thing about doing it at the object level is that it constrains us in using a certain type of logic.
I mean, we can always write a sentence in a claim that uses a certain type of logic. So since we're supporting language, we're supporting everything that the language.
What I'm saying is, if we support DNF explicitly as in the object model and the class model, we are kind of making, planting a stake in the ground. How we model logic is propositional logic. No fuzzy, no Bayesian, no this, no that. That's what I'm kind of resisting a bit. Tim, you're mute.
We don't plant flags here. We propose a model for what works with the examples we have so far.
Yeah.
The moment we find the example that blows that concept out, we need to model a formula class or whatever.
Yeah.
Go for it. But yeah.
Like
I would say, let's.
This can be modeled this way. I mean, you're saying let's model it some other way. It's true, I'm giving an advanced thing, but you also have to say why not this way?
Sure.
Because the formula has to be parsed, which I agree is a nuisance. By the way, I even agree with that.
Yeah, and language, as we know, has ambiguities that don't match formulas. It would have to be a formalized language of some sort. You have to formalize it in some way.
No, absolutely. I was going to say, I would even say I'd have the notion of logic system and say this compound claim uses this for logic system, and so this is the parser you have to use to parse this formula, because this is the parser for this formalization of this logic system.
But yeah, but a model would help constrain, because I mean, at some point you just get hand wavy, and your claim could be a string, and you assume that there's some language parser that turns your claim into whatever uses you needed in the system. At some point, you're just modeling
Yeah,
a bunch of characters.
You're correct, and it's true that I would expect the parser to give me an abstract syntax tree of some sort, and maybe I should actually say the formula is an abstract syntax tree, and worry about, abstract syntax tree is logical operator and claim. We could do it that way.
I'm still in favor of modeling, like choosing one useful logic right now, like Boolean logic, and modeling that in the model explicitly without formulas.
Mm-hmm.
Make it expressible.
Let me just finish the operator, leaving that one undefined. Claim components AST is a claim. So do I need compound claim anymore? No, AST is a claim. No, I don't.
Do you need? Yeah, it is the compound claim.
Yep. So let me and claim atoms does a recursive search, and the components can also be compound claims.
You have claim components. Remove that, I think. No, or is it a claim? Like, I'm confused, because you have atoms and you have.
I'm removing
claim components. Yeah.
I'm calling them components. Yes.
Wait, but what is?
No, Tim is talking about line 23.
Yeah.
What is atoms? It's about saying, oh, I want
23.
This. Oh, 23. Claim what it should be.
What is 24 is a method. What does the method return you?
It's
a function.
It's the set of atoms. Like the component can also be compound claims, in which case they're not atoms. But so you'd go down recursively on the composition operator until you reach an atom, and then you return all the atoms.
I see. Okay, understood. Yeah,
and compound claim is basically the conjunction of components.
No, it can be a conjunction, can be a disjunction. It's a node in the abstract syntax tree, right? And it can have another compound claim as component, because the abstract syntax tree is a recursive structure.
Yeah, understand.
And atoms yields the leaves of the tree.
Understand, but I'm wondering if it might be better to fix, like have a class that's fixed on the what is it, the AND operator.
Well, those are the logical. We'll have logical operator subclasses. We'll have AND as a logical operator. Logical operator is a class, or it could be an enum, and then you could have AND or.
I'm just saying, like, I would model the DNF as a set of sets, basically.
What you could do, and I agree with you, is that compound claim could be an abstract class, and then you could have a conjunction as a concrete subclass of compound claim. Is that what you're saying?
I'm saying I would only have the
I'm
conjunction
happy with
class.
that. That's very reasonable.
No, but wait, I'm saying I would not have this general compound claim thing there. I would only have the conjunction class.
No, because you also need the disjunction class and the vector product class, and all of those are subclasses. So yeah,
Yeah,
I totally argue for a.
But right now you're trying to model an AST in the model, right?
Yes.
Yes, and I'm saying we could structurally, because for DNF we only need the two operators and an OR.
We do.
Yes, only conjunctions and conjunctions.
Yes, disjunction and conjunction. Yes.
And I'm saying we could have the conjunction as one class and model the because we already have this.
Okay, that's an alternate model.
Yeah.
Let me do it as an alternate model. I'm not keen on it for reasons, but it's perfectly valid to ask for it to be modeled. No, this is not.
Because I'm saying we have wait, is it conjunct? We already have an implicit logical operator in the model. For,
not anymore.
If something has multiple premises, for example, right? Then we said it's OR.
One second. Conjunction, no logical operator, and I think that's what you want. The diagram's horrible, but let's just focus on the logic. Am I being a good secretary here?
Yes, that goes in the right direction. And I'm saying we, in the model before, we had the disjunction already in the model. So
we had the disjunction implicit in that the premise had multi-claim, but we reverted on that because we'll say, oh, we'll just use a conjunction in this case. The conjunction, and here the premise we could say could be either a conjunction or an atomic claim, or a disjunction, really, because it could happen that the disjunction, will we bother adding a disjunction if there's a single element to the disjunction? It's a question.
It's still fine, but there are ways to simplify it.
Yeah, the question is, do we want the abstractness, or do we want to say this is always a conjunction? We could.
I'd say we can say this is always a conjunction, and we can have one class less in the model, right?
No, that doesn't give us one class less. Well, oh, I see. Make the support into the conjunction.
Yeah, somehow I'm not very clear about it. So
it could be done, yes. I hate it with.
No, but then you get back to the problem of you can't just state a compound claim. Then it has to be put inside a support.
That's a very good point.
In the context
yeah,
of
true.
Thank you, Tim. The reason I hate it is that, okay, how do I do my vector? How do I do this? How do I do mathematical formula? Which is a need. Bayesian formula.
You're basically, the alternative you're proposing is basically saying, okay, we model a formula with operators.
Yes.
In the
now one thing that is possible, which is a kind of in-between thing. Let me now comment that out and take mine back. Right now I had logical operator like an enum, right? What we could do is make it implicit. Make this abstract class common claim. And then have compound claim, disjunction, compound claim, conjunction, blah, blah, blah. there I'm absolutely not imposing and the vector product and whatever. And there I'm not imposing conjunctive normal form in the model. But do we want to in this case, right? Sometimes it makes sense to have A and B or C because it's a valid formula and it's simpler than the conjunctive normal form. But if we're going to have an AST, we could decide to allow this.
Yeah, I could live with that.
So these are two alternative models. This one I think is more supple in terms of different operators. It's easier to extend with something other than propositional calculus. But there's no question that if we're following the let's only do what we want, this is, and let's only write a model for what's being proposed yet. This isn't valid alternate model for what we have so far.
Now, we have a problem here with this model.
Tell me.
Which model is this that we're using? This is the TIM model. We've been doing this off of the TIM model, in which case we don't have a problem. The problem I was going to state is in the Stephen model, you have to state for each and every claim in the compound claim whether you're using the claim or its negation.
Yep.
But in this case, it works because these are two separate claims. Yeah.
Correct.
I was always more comfortable that way, yes. You know what?
Yeah,
it's
I
time,
still
folks.
think you have trade-offs, but that works. Yeah.
Yeah.
Once again, we can't do a single, but we can't do a single item, but yet it's very productive. It's been excellent.
No,
I'll be interested. We might have to go over this all over again when Steven's back, or at least.
No, he normally does watch the thing. I'm actually very admirative of his diligence in actually watching the recordings.
Feedback, yeah, it's just that getting his feedback in the Slack is
I
hard.
prefer we did it live than in the Slack. Yes.
Right.
Hello, Stephen. I was going to have a comment on our last conversation. I said, I'll wait till he's there.
Yeah. All right. Then we'll call it a day.
We'll call it a day. I'll check
your
this
day,
in.
Felix.
Yeah, tomorrow I thought about talking a bit more about our general goals. Like, is there do we set a limit on how deep we dig, for example? That's something I would be interested in. Or because if there's no limit, then there's actually no limit, because I think we can dig arbitrarily deep. I just wanted to talk about stuff like this, like because to get practical, to build a system that will be used by people, we have to draw a line somewhere. And I'm interested in this line, basically, where that line is.
And I will show enough restraint not to respond to that now and save it for tomorrow.
Yeah, exactly.
Sounds good.
Yep.
All right, then have a good afternoon, guys, and I'll see you tomorrow.
You too.
See you tomorrow. Ciao, ciao.